So let's talk about the Hawksby paper. So I had you read the introduction and conclusion of the Hawksby paper. And the reason behind that is reading the introduction and conclusion gives you a good way to kind of like set up things in your mind. And then after this lecture, you should be able to go and read the middle parts of that, because this is going to be very helpful for thinking about how do you use the force laws, what three strikes and out laws to figure out what's the impact of these laws on the educational team of either women or black men. Right?
Pass those down.
So, and the Logan paper takes a similar approach to this as well. And so we'll have you on to this exercise. You are able to read that paper, which is a fantastic paper, so definitely read that in its entirety as well. But let's take a look at, is this dark enough for folks in the back? Can you see this? Okay. All right. So, how teachers, let's see if that's darker. Okay. All right. Let me know if this gets too faint, please. How teachers use affect how teachers' unions affect education production. What's the data set that is used here? This is awesome. Okay. So the first thing to do, let's talk about the data, right? And so the data that's used here is data from the census of government. So the data is from the census of government in 1972, 1982, and 1992, right? And Hawksby has data on every public school in the US, so like just very good data. And for each public school, she has expenditures, teacher pay, student enrollment, and demographics. And the basic idea is to see what's the effect of unionization on per pupil spending. What's the effect of unionization on teacher compensation? What's the effect of unionization on whether students drop out, right? And so the basic question is, well, let's say fundamental. Fundamental research question is, how does the unionization of teachers affect the allocation of resources affect the allocation of resources? How does the unionization of teachers affect the allocation of resources in schools? And also student outcomes. For example, probability of dropping out. Everybody with me so far? And so we need data on the relevant resource allocation, and then we also need data on utilization. So those are the two things that we need data on. Okay, so look with me rather at the table on page 682, table 1. Right? And so in table 1, if we look down the columns, we see summary statistics from 1963 all the way to 1992. And this is going to tell us how many states are going to be covered by collective bargaining agreements where unions are able to bargain collectively. So in 1963, how many states have collective bargaining agreements? This is table 1, the third column. 1. And by 1996, how many states do we have there? 92, sorry. 36. And so over time, what we see is that the ability of unions to implement collective bargaining on behalf of the teachers is increasing over time. And so what's going to happen in this paper is we're going to look at, well, what happens as schools unionize to the mix of inputs that are going to be used. Okay. Now, for illustrative purposes, let's focus on per pupil spending as one of our outputs, right? So, for example, consider per pupil spending. This is going to be on page 687. So on page 687, if you turn there, you'll see that equation 13 has per pupil spending, equation 14 has teacher salaries, equation 15 has teacher ratio and dropout. We're going to really focus in on per pupil spending because all of the results are going to be very similar in terms of the structure. And so we're going to really burrow deeply into per pupil spending to understand how she sets the regression equation. And so what she's going to do is take the log of per pupil expenditure of school I in time period T. We have a panel of data, and I'm going to add another subscript, which is going to be state S. She doesn't have this in this. This is not in the paper, but I'm just going to add this for the exposition, and that's going to depend on whether the school is unionized, and then we have a lambda, which is going to be like this. So if the school is unionized, it's going to be 1, and then you're going to have a change in spending by a lambda plus mu times WIT. So this is equal to 1 if school I time T is unionized, equal to 0 otherwise. Okay? And this is going to be demographic factors. Everybody with me so far? Okay. And then we're going to have, I'm going to call this I. She calls this script because C in the paper, but that's difficult to write. This is going to be the school fixed effect. So think about it as like, this school has an endowment. An endowment probably isn't like a great example. Yeah, this school has an endowment that pays out a fixed amount of money like every year, right? This school is always going to have more money per pupil just because it has that endowment, right? Or there's something special about this school. Just, this is like the thing that's specific to this school. So this is the school fixed effect. And it's a fixed effect in the sense that it doesn't change over time, right? The demographics of the school change over time, whether it's unionized, that changes over time because we see that over time more schools are becoming the problem. More states are including unionization, so the probability of becoming unionized is increasing. So this is the school fixed effect, right? And this is going to be unobserved, but we're just breaking this out. And then what we're going to have is some kind of a time trend. I'm going to call this, what do I call this? I'm going to use the letter rho times T. And so if per pupil spending is just increasing over time in a linear way, in the same way that GDP seems to be going at a 2% per annum clip, this rho is going to capture like just the natural growth rate in per pupil expenditure. Everybody clear about this so far? Okay. Oh, if school I in time t is unionized, this is going to be equal to 1.
Oh, okay.
And if school I in time t is not unionized, it's going to be 0.
Okay.
This is the key variable. Does everybody follow that? Okay, great. And then on top of this, so this is like a time trend for the growth rate in spending. This t here is actually representing time. So this is time equals 1, time equals 0, right? So time equals 0, we're going to be at the base level. At time equals 1, we're going to get $0 more per pupil because of inflation, for example, or because of, well, we want to use normalized dollars, but just because of time expenditures in school is increasing, right? And then we're going to have this unobservable epsilon IT. So these are the unobservables. Are there any questions on this before we start to dig into this?
What does it say next to a T on that first
T is,
little?
this is just time. This is literally just time.
Okay.
So this is like, you have like t equals 0, 1,
Okay.
and so with every increment in the time period, we're going to get like a growth in per pupil spending, or like a decrease in per pupil spending if this parameter here rule is negative.
Okay. But then on the first little subscript, like the first note, what does it say right next to that T?
This is I comma t.
Or no, like below.
Is equal to 1 if school I in time t is unionized.
Unionized. Okay, thank you.
Any other questions before I jump into this? Okay, it's 12:05. Okay, this is good. We have 10 minutes, which is good. Any questions? Okay, good. So, what is the parameter of interest? What is the parameter of interest? Who can tell me? Lambda. That's the parameter of interest. Okay. And we can change this to student-to-teacher ratio, salaries, and so on and so forth. That, when you go back and read the big, you'll be able to do that. But I want to explicate the methodology. Okay. So the data we have is for 3 years. So we have 1972, 1982, and 1992, right? And so the first method, this is the parameter of interest. Methods to get lambda. The first one is just run a cross-sectional, let me just say it in English, run a regression from equation for each time period. Separately. And so in this case, what we're doing is we're just going to be comparing, in some states, at time period t, some states are going to have teachers being unionized, and other states are not going to have teachers being unionized, right? And so what we're going to be doing is we're just going to be saying, okay, are the states where teachers are unionized, do they spend more people than the states that are not? That's what the interpretation is going to be on this lambda that comes from the cross-section, right? That's what's going to be happening. We're not looking at what happens to an individual state in terms of its per pupil spending as it goes from not being unionized to being unionized. Does everybody understand that distinction? Are there any questions about that? Okay. So we can just run this regression. Now the problems with this regression is we can't account for F, and we can't account for this time trend, because we're only looking at a single year of data. Does everybody understand that? Okay. Now, the problem is we have 2 omitted variables. Fi and the time trend. Okay. So, method number 2 is going to be what's called the first difference. And we've seen this before. So what we're going to do in the first difference is we're going to say that this fixed effect here is going to be the same in 1982 as it's going to be in 1992 as it's going to be in 1970. And so we can look at the differences in per pupil spending between those 2 years. And what's going to happen is we're going to subtract out this fixed effect. Does that make sense? And then we'll get the changes in unionization between those time periods, the changes in the demographics, plus no more fixed effect. And then we just get this row term here from the time frame. Because over that time period, we're going to get an increase of spending by a factor of rho. Does that make sense? Okay, so the first difference. So I'm going to just call this YIT, just for simplicity. So what we do is we take the log of yi in time period t plus 10. So this is minus the log of yi in time period t. So time period t, for example, could be like 1972, and time period t plus 10 could be 1982. Does everybody understand this so far? What we're going to get is that's going to be, the lambda is going to be the same in front of both of those things. So we're just going to get lambda times the change in unionization for school I from t plus 10 to t. Does that make sense? Plus mu times the change in omega I from t plus 10 to t. Any questions so far? Plus, and when we do the difference between these 2 rows here, we're just going to get a row. Because in time period t equals 0, it's just going to be 0. In time period 1, it's going to just be rho, right? And we're going to get plus rho, and then we're going to get plus delta epsilon I t from t plus 10 to t. Any questions on this so far? Let me just stop there for 1 second. So the problem with this cross-section regression is that we had the fixed effect, and we also had this time trend that we would not capture. We couldn't capture the time trend because we just have 1 year of data. So we're comparing places that have schools with unions versus places that don't in 1972. When we take the first difference, what we can do is we can look for how are differences in per pupil spending changing. Since the school is the same between 2 time periods, the fixed effect is not going to be what's going to be driving the per pupil expenditure across these 2 time periods, right? However, but even after we do this first difference, we're going to pick up this term here, growth, which is the growth rate. So the problem here is we have a growth rate rho that we can estimate. We can, right? And so the way that we get rid of rho is we take a difference in difference. So we have this difference between 1972 to 1980. We can also compute a difference between 1982 and 1992. And between those 2 periods, 1982 to 1992, we're going to also experience a growth rate of rho. And so when we subtract those 2 differences, we're going to get rid of this growth term here. Does everyone, let me say it in words. Okay. Can everyone see you probably can't see right here, so let me go over here. Okay. So method 3 is going to be a difference in difference. So let's look at, this is equation 2 here. So we use equation 2 to get the difference in spending between 1972 to 1982 and between 1992 1982 to 1992, right? In both of these, we get a growth rate of rho. And so how can we get rid of the rho? Does everybody understand this? So when we take the difference from 1972 to 1982, there's a growth rate of rho that's not explained, right? When we take the difference from 1992 to 1982 to 1992, there's a growth rate of rho that's also not explained. When we take the difference between those two things, the rho's disappear. Does everybody understand that? Any questions on that? And if you guys just give me just like 1 minute, like literally 1 minute, I'll be done. And we take the difference between these two to eliminate. Okay. Now that's conceptually what we've done. Oh, we actually do have 1 minute, it's 12:14. So I'm not stealing any time from you. Okay. If you look at table 3, which is on page 670. Okay. So this table is a regression of log per pupil spending on whether it's unionized or not, and then there are also some control variables. So like, is it a metropolis area? Is it, what's the population? What's the poverty rate, etc. And in the first 3 columns, you see the estimates from method 1, which is the cross-sectional regression, which is here. We just run it on a given year. And so what we see is that for 1972 to 1982, the results are not statistically significant because the estimates are not bigger than twice the standard deviations, right? But there's potential for omitted variable bias because we can't get what the fixed effect is, and we also can't get at the growth rate. In the next 2 columns, we do the first differences, and the first difference is they take out the fixed effect, right? But they can't account for the time trend. And what we can see is that when we take out the fixed effect, we actually do see that unionization results in an increase in per pupil spending of around about 3%. Does everybody see that? So this is in column 4. So in column 4, we see that unionization results in a growth rate of about 3% from 1972 to 1982. But we see from 1982 to 1992, there's no growth rate there. Like it's not statistically significant. Now, when we do the difference in differences, what we get is we're able to take out the growth rate here, which we couldn't get out from just using the individual first difference, right? And when we use that, then we actually find a significant effect that's also 3% for the difference in differences. Okay. The last column, and I'm going to end on this, is the instrumental variables approach. So here, we just used whether the school is unionized or not. But what they do in the paper is the unionization can be endogenous. So like other things are unobserved. And so what they do is they take whether the state passed a law that required unionization or that allowed for, whether the state passed a law that was a right to work law that allowed people who were not unionized, whether the state passed various laws regarding unionization. And they take the passage of those laws to be an instrument for whether teachers in the school is unionized. Teachers in the school are unionized. And what you find is that there's a much larger effect on per pupil spending that's there with the instrumental rate strategy. You have the tools to be able to read the paper. Just as you go for fall break, read those 2 papers among your group, decide whether your group project is going to be on the unilateral, the effect of unilateral divorce laws on women's educational investment, or the 3 strikes you're out, and then like start to put together the data sources that we use to answer that question. Thank you guys very much, and have a great fall break. Yeah, no, go.